Well, welcome everybody. Thank you for joining the webinar about ITS sensor overload. It's going to be largely about our Blue City solution. But we were talking. I live in a city. I live here in Portland, Oregon, and all the intersections around here. Part of the thinking around this, when I drive around every day, I see, now that I'm in the industry, I look, and the intersections here. I was looking the other day, and I was seeing we had a dome camera, like 4 radar sensors, a bike lane detector, a bunch of sunlight detectors, and loops all over the intersection. Um, and what we're doing here with Blue City is, these solutions are great. It's been built up over the last 20 years, and they've all been, installed to serve a purpose. Uh, but none of them really do, they all do a single thing at an intersection. And so we're excited today to share what our Blue City solution does, but it really enables these intersections to do lots of things, to do stop bar detection, to do pedestrian detection, full multimodal detection. Um, but the capabilities of the system are great, and we're just excited to share it today. So we're going to be going through with Atai Dadone and Asad Lasani on our team here. Atai is going to be going through just a bit of how our system works, and Asad is going to be going through in more detail just the fundamentals of, what Blue City, what our software system can detect at intersections. So before we fully dive into it, I just as the MC here, I'm responsible for a little bit of housekeeping. So everybody here, if you do have to drop off, don't worry about it. We are recording the webinar, and so we'll send out a recording after this to everybody who registered. So if you want to come back and rewatch something, or want to come back and see something you missed, you'll have a recording to do that. The second piece is we're leaving off a little bit of time at the end of the webinar for Q&A. So if you have questions about anything that Asad is talking about, anything that Atai is talking about, please put the question. There's a little module, a Q&A module that you should see in the webinar interface. Put your question in there. We won't stop mid presentation, but we collect all the questions as we go, and we'll answer them as best we can in the order in which we receive them at the end of the webinar. And I'm logging all these questions as you type them in, so please don't be shy typing questions in as we go. So with that, then I'm going to hand it off to Atai here, and he's going to tell you a little bit more about Ouster, who we are and what we do, and more about Blue City. So take it away, Atai.
Thank you very much, Tom, and good morning, good afternoon, good evening from wherever you are connected with us this morning. And I'll start, as Tom said, by talking a little bit about who we are, who is Ouster. We're the largest US-based digital 3D LiDAR manufacturer today. We'll talk a little bit more about what does it mean 3D LiDAR, what does it mean 3D digital 3D LiDAR, but we were founded in 2015, which is now almost a decade ago, and we are a public company traded at the New York Stock Exchange. And over a year and a half ago, we merged with Velodyne, thus getting a combination of products from a Blue City that was acquired prior by Velodyne from Velodyne itself, and from Ouster internal development, and really created a very, very strong portfolio that can now provide dedicated solutions to different verticals in the smart infrastructure market. And that strong portfolio has really translated into a lot of demand from the market, which is today showing in over 400 installations, almost 500 installations of our software solutions that are Gemini and Blue City already. We are distributed around the world, present both in the Americas, in Europe, in Asia, and the Middle East, with above 300 employees and almost 1,000 active customers distributed in about 50 countries, which is a real global operation. As a company, we're ISO 27001 certified. All our products are also NDAA compliant, and our sensors are Buy American certified. All our LiDARs are also IP6869K certified, which means that they can really be put in very harsh environments and sustain them. And this is part of what we'll talk about throughout our presentation today, which is really the reliability of our solutions and systems. With that aside, if we can get to the next slide, what has really put Ouster ahead of the pack in the lidar industry has been our strategy from day one to identify the fact that there are many different markets that can leverage our lidar technology, and as such, we've been becoming really a default sensor in industrial, robotics, automotive, and smart infrastructure markets around the world. That variability in conditions and locations, whether it's geographies and type of environments that our sensors have to be installed at, it means that we have had to really learn how to make sure that our sensors sustain and work and perform across all these different harsh environments. As you can see here, some different examples on this slide, but this is just a really just barely scratching the surface of the different things. So that means that all our customers benefit at the end of the day from the accumulation of that experience that is brought back into our sensors and apply, of course, to every one of our customers and partners around the world. Let's talk for a second about the fundamentals of how lidars work. Lidars essentially is an acronym for light detection and range. We are using light, in this case, lasers that are shot out of the sensors and looking for reflections coming back from objects in space that are coming back into the sensors. These reflections we're able to effectively measure the time since we shot the laser beam until it came back from the object, and therefore determine with a very, very high accuracy of centimeter levels where exactly that object is in space. The result of all these reflections, every time that we have a reflection, we create a pixel that we put in space. And the collection of all these pixels together is what we call a point cloud in the LiDAR industries. The more lasers you're able to shoot out from your sensor, the more points you'll have in your point cloud, and the higher the resolution will be. And just like we enjoy higher resolution on our TVs at home, the more resolution we have on the point cloud, the more details we're able to get, and the further range we're able to detect objects and classify them in space. So as you can see on the left-hand side on this slide, there's an illustration of how the Ouster lidars work. What's quite unique about the Ouster lidars is that they have a fully digital architecture, which means that all these lasers are shot from a single chip that is effectively carrying little laser cavities, that from each one there is a dedicated laser channel that is shot out of the sensor. That means that all the lasers are always aligned and calibrated, and there's never a need for any type of maintenance and calibration work on the sensor in its entire lifetime. The On the reception side, we also design and develop our own CMOS sensor. And just like in digital cameras, we're creating our own CMOS sensors that go into our LiDARs. And these CMOS sensors are effectively doing the job of translating all these lasers coming back from all the reflections into what you see on the right hand side, which is the point cloud. Every year or so, we update these CMOS sensors. And each time that we do that, we're able to improve our performances, improve our capabilities and functionalities of our sensors without having to change anything in the sensor's architecture. And this is really the strength of our architecture that allows to put all those capabilities in such a small form factor. These sensors that you see here in the picture are actually smaller than a coffee mug. The ability to take that point cloud and translate it into objects and seen in space and giving those insights into our customers, this is really the strength of what we're building together. When we think about the ITS industry, what we're seeing is that there are effectively a lot of challenges all around the world whenever we're talking to departments of transit or transportations or cities and municipalities. Um, while each one of them is unique and slightly different, we can definitely see some common trends and common challenges that the industry is facing as a whole. Of course, the continuous push and struggle to become safer. And as you know, our roads have changed a lot in the past decades. We can say that probably 20, 30 years ago, our roads were mostly dedicated for cars, especially in the United States. As time advanced, there is a push by cities and municipalities and the people themselves to enable more forms of transportation, micromobility, more cycling because of sustainability as well. We have the electric bikes, the e scooters, and of course, a lot more pedestrians on the roads, which means that a lot of the tools that we've been using before are not as applicable anymore today. And which also means that there's a lot more road users that we call the vulnerable road users that are outside of their car and are getting and this reflects in the numbers. We're seeing 37% incremental cyclist fatalities in the past decade in the United States alone. And that trend is really hurting, and I think that it's very common for a lot of cities and municipalities to pay a lot of attention to how we can use technology to reverse that trend. To reverse a trend, we first need to understand what's the baseline of where we are. And it's still very hard to collect accurate data over a significant amount of time that will make it meaningful enough to create a baseline of where we are at today. As you can see in the picture on the bottom right of this slide, this is a picture taken a couple of months ago. And this person is actually counting with dials for each lane how many vehicles and cyclists and pedestrians are in that intersection. Of course, this is prone to a lot of errors, and it's very hard to do over a significant amount of time. There must be a better way of doing that. We have seen the augmentation of use of cameras in our industry, and of course, they're great, and there's been a lot of advancements in AI and computer vision, but there are a lot of challenges with video itself alone. As you can see the picture on the center of this slide, there's situations where you have sun glare or harsh weather conditions, or dark conditions without light in the night, or dusk or dawn, that makes it very difficult to understand what is going on in the road. And when you don't know what is going on in the road, it's very hard to react to that situation and provide accurate traffic control, monitoring, and of course, safety alerts and functionality. And this is, out of these challenges was born the idea of the Blue City platform, that Assad will present to you today. Assad, if we can move on to the next slide. So now that we understand what is LiDAR and how it works, the fact that we are using our lasers to see the world means that we see the world not in 2D, but in 3 dimension. That means that we understand depth, we understand scale, and we can derive and measure instead of infer where are things in our roads, on the intersection, on our ramps, etc., and provide very, very accurate 3D spatial intelligence, um, even for slow and small objects like pedestrians, for example, that is very hard for other technologies. The ability to see the world with our lasers means that we're independent from any external lighting or weather conditions. And this is why we can see equally well 24/7, 365. And this is very, very important, and something that is very, very hard to do with any other technologies. And we know that there's a lot of things what we're trying to do, for example, in an intersection. We're trying to do detection, traffic control, we're trying to get safety analytics, we're trying to understand traffic performance measures, and we're hopefully modernizing our roads with V2X. So if we need a sensor for each one of these systems, that's where the sensor overload is coming from. But there's an alternative. There's a possibility to just use the Ouster Lidars with the Blue City platform that will conveniently provide you a solution that is easy to install, that is non-intrusive, that can be installed on the poles and not buried on the pavement, and at the same time provide you with competitive prices and costs, both upfront and for maintenance and operation, the ability to really perform above all other technologies. And how we do that is exactly what Assad will be presenting to you now. So, Assad, the floor is yours.
Thank you very much, Itai. I'm happy to be here today talking about our Blue City solution. And what we try to do with Blue City is basically building a turnkey solution. The reason we call it turnkey solution is because um, all you need to just get the system up and running is an AC power and maybe internet connection. And the system that we are providing as a part of Blue City Bundle, it has basically two components. What you see then on the left side, which is our detection system that has the edge computer, perception software, and all the ITS logics running on the edge computer to convert the raw LiDAR data into object data, into actuation, and also converting into formats that can be ingested into RSU for V2X applications. And these are all running on the edge computer locally. There's no internet connection needed for running this, operating this solution. And this is really targeting all the low latency application. And then on top of this, our detection system, we have a data analytics platform, which is a SaaS model that basically gets all the object metadata from the detection system and also some other source of information like traffic light status using NTCIP to generate insights about how people are interacting at the intersection with respect to the safety, planning, and signal optimization. So what I'm going to do today is going through some of those applications and then show some live data from our current deployments with our latest bundle. So I'm just going to connect to one of our current deployments. So this is a project in Colorado, which we have two of our OS1 sensors installed at the intersection. We have LiDARs at two different corners of intersection, and they are all connected to our edge computer. Our perception is basically detecting and classifying different type of road users. So this is the 3D perspective that you as an end user can get access from your traffic management center. As long as you have you are on the same VLAN as the edge computer, you can actually enter the IP address of the edge computer, and you can actually see this 3D view from your office, which is a great tool for you to understand the traffic pattern and see, and as a surveillance tool. Something that you probably noticed is that our LiDAR is generating a near IR image from the intersection, and this is a part of our solution. There is no camera installed, and as you can see, it's clear enough to see what's going on at the intersection. And then on top of this, so we have two LiDARs, so you can actually switch between different LiDARs. You can see all the traffic flow, and then you can even see like this 3D perspective of the intersection. So what we do with this information is that the perception is generating object metadata, which if I select one of those, you can see that this is a vehicle, and there is a tracking ID, there is a speed, there is a dimension of the object, which is very important, and also subclasses. For example, if it's a trailer, tractor, if it's a passenger vehicle, truck, buses, we subclassify objects based on we're using our perception software. And then, as you probably saw, this is really like a multimodal detection system, which if there's a pedestrian, you're going to see a pedestrian. So you will see some of those cases in other demos that we're going to do today. And then this information in real time is passed into our ITS Edge app, which is running on the edge computer. It's another part of our software solution, which basically converts all the object metadata into logics for communication with the traffic controller. So I'm just going to connect to the same intersection on our configuration tool, which basically we can generate a digital twin of the intersection. So if I scroll down, this is live data, again, coming from the same intersection. And as you can see, we have a bunch of different type of virtual loops that we assign. I'm just going to disable everything and just keep the presence loop, because I want to talk a little bit about the actuation use cases. So at this intersection, we have communication with the traffic controller over NTCP. We can use NTCP for traffic actuation, but for this case, we're using SDLC for communication. That's why you see both connections are available. And then, as you can see, using our configuration tool, you can actually draw some virtual loops. So we have some stop bar loops for vehicles, and also we have some virtual loops for detecting pedestrian and crosswalk. And each of those virtual loops can be customized. You can easily delete those and edit those just to make sure that it addresses the needs of this intersection. And then you always have option to draw those virtual loops either on Google Map, and if the Google Map is not updated, so you can switch to Point Cloud Viewer. So that's the way that we use our system as a multimodal actuation system. And as I mentioned, on top of our detection system and using for actuation, we have a data analytics platform that I want to show you some of the insights that we are extracting from this intersection and a couple of other deployments. So when we click on our overview tab, you can actually see a list of all the analytics that we are providing. I would categorize them into three different type of analytics. One, getting access to count and speed as a part of planning data. Second category is targeting safety. And the idea here is that instead of just looking at crash data when it comes to the safety improvements, so you can basically look at how people are interacting, like detecting red light violation, detecting jaywalking, which we call it outside of crosswalk event, as well as conflict analysis using post-encroachment time. And then the third category is targeting signal optimization and basically getting access to signal performance measures like occupancy ratio, phase interval, sleep failures that city planners are using to basically look at the efficiency of the signal optimization at the intersection. So we go through some of those metrics. So if I start with the count data, so as soon as you open the count tab, you're going to actually see a count information for all 4 approaches that we have at this intersection. So you can see how many buses, passenger vehicle, trucks, how many pedestrian and cyclists. By default, this is for the past 24 hours, but if you want to look at, let's say, past 3-4 days, you can select multiple days, and then you can actually see the pattern of the traffic volume. And we are counting per turning movement, so how many left turn, true movement vehicle, and right turn per each approach, and for all 4 approach, all different type of your road users. With the system, you have the option to download this information as an Excel file, and we build our system based on Open API architecture, which means that you can get access to raw object data or all the analytics using our APIs. Which means that if you have your own data lake or data visualization tool, you can potentially use APIs to pull all the analytics and data instead of just manually logging into our dashboard. The second part of analytics, as I mentioned, is targeting near misses and safety. So I start talking a little bit about conflict because this is really important aspect of the system, feature of the system. So there are different methodologies to detect conflict or near misses at the intersection. The factor that we are using called post-encroachment time, or PET, which is whenever we detect a conflict between trajectory data of road users, we capture the time difference between the first object leaving the conflict zone till the second object arriving to the same zone. And that is registered as a conflict at the intersection. And this is happening 24/7. And as soon as we detect a near miss at the intersection, we record it with some other attributes that you can see here, which includes type of road users involved in those conflicts, of course, the timestamp, turning movement, speed, and the value of the PT. So by default, when you visualize this data, it pulls all the near misses for the past 24 hours with PT less than 2 seconds, which are considered as critical conflict. But you can simply play with those sliders and change the data visualization. So now that you have this map, you can actually select those and you can actually see all the disaggregated information, which, as I mentioned, includes the location, timestamp, turning movements, or type of road users involved, a short video clip of the LiDAR from bird's eye view that you can use for validation, speed, PET value. And if I sort it based on the PET value from low to high, you can actually see there were, like, for example, it was a near miss between a car and a cyclist. The car was, which was the leading object, or the first object, was turning left, and then there was a bicycle getting into the same zone. And if I play this video, we should expect to see like that event. So I'm just going to zoom in a little bit. As you see, there is a area that we typically highlight to show the area of the near miss. This was a close call between left turn vehicle and this cyclist that was captured by the system. And this is happening 24/7. And if you really want to look at a specific type of interaction or type of road users involved, you can play with those arrows. And as you probably saw, when you select the object, the conflict, so you can actually download this information as an Excel file. And then you can just overlay this information with some other type of information like weather data or crash data to extract more information from our analytics. And everything is running 24/7. So if, for example, if we want to just look at a near misses that the first object is turning left, and then the second object is another car which is going through, so you can actually select left turn movements on your leading object, and then just select the true movement vehicles. And then now everything is sorted, so you can actually select those again. And if you want to sort it based on the PT value, you can do that. And then again, you can see a video clip as well. So this should be an area of the conflict between this true movement vehicle and then the left turn vehicle. So I'm just going to play it again. So as you can see, this was a true movement vehicle and then left turn vehicle. That was a close call that was captured by the system. So the other analysis that we're providing is targeting red light violation. So since we are connected to the traffic controller and TCP, we can actually see a list of all the red light violations. So I'm just going to select more date, couple of days of data, and then pull the historical data. And then so if let's wait for the data to be visualized. So these are different phases at the intersection. If I want to look at one of the phases, so for example, there was a red light violation, that car entered intersection around 8 seconds after light turning into red. So if I convert it to the list and then sort it, this was actually the event that I was showing there. So this car entered intersection 8.2 seconds after light turning into red, and the car was going northbound straight through. And if typically there's a video clip of that, so you can see this vehicle is getting to the intersection and it's just crossing. And this happened around 5 a.m. in the morning based on the timestamp. So these are the type of analytics that we can extract from the red light violation. And then there is another analytics that which we call it outside of crosswalk event. This is again data for the past couple of days from one of our current deployments. And I chose this intersection because, as you can see, there are a lot of people that they are just crossing the intersection, not using crosswalk. And this could be a really critical safety issue, especially at this intersection that is going downhill. And then during winter time, which the lighting is not good and the visibility is not good, this could cause a safety issue. And one thing that we are doing for this type of application from the real-time perspective is that we are basically flashing a beacon to warn drivers whenever we are detecting pedestrian on specific area, which in this case is this location. And when it comes to the analytics side of it, so you have the list of all the events. So if you want to select that conflict, so you can actually, again, click on play, and then you should expect to see a video. So this is the pedestrian that is crossing the crosswalk, the street not using crosswalk. And this happened at around 3 a.m. in the morning, which typically vehicles are driving faster and they are not expecting a pedestrian at this location. So this is another type of analytics that we're providing as a part of segregate safety analysis. So going back to the intersection, we talked about the accessing to signal performance measures. So we generate different type of parameters like occupancy ratio, which is one of them, and it basically pulls the percentage of a time that a virtual loop backhoe stop line is occupied within that phase. And this measurement is calculated during green, red, and first 5 seconds of red. And when we overlay this information, whenever we detect a occupancy ratio higher than 80% for a specific phase for the green time, and then more than 80% during the first 5 seconds, it shows that there is a residual demand, which means that green time is not enough. And that's the case that is going to be detected as a split failure. And if we scroll down and open the split trend, you're going to see that this phase, we had 100% of time. Phase number 6 was there was a split failure. Again, which means that there is a residual demand that we couldn't serve because the green time was not enough. So, and if you look at, let's say, yesterday data, so you can actually see the full pattern of the split trends within your traffic signal optimization plan. And then if you want to see if you see a lot of spare capacity, which are those blue lines within a specific phase, you might play with the signal timing to minimize those black split failures at the intersection. This is, again, another part of our solution, our data analytics platform that is generating all this information 24/7. So you don't need to send someone to generate this information or getting access to this through like hiring a consultant. everything is generated 24/7 as a part of our solution. So we talked about the data analytics platform and use of the solution for intersection. But something that I want to talk a little bit about is non-intersection use cases. So this is a project in Virginia that we used our system for wrong-way detection. This is a ramp area that we are covering with our OS2 sensor. And within this project, the customer evaluated our system from the false positive and false negative perspective. And they had different test scenarios that there was a combination of pedestrian walking in ramp, wrong way driving, and a combination of vehicle and pedestrian at the same time. They wanted to see what percentage of time the system can capture those events. So this event can trigger a 3D event recording that I'm going to show, and also we can also trigger flashing beacon because we have a dry contact output as a part of our solution as well. So with our I'm just going to connect to that highway because the system is online to just show you quickly some live data. Let me just connect. So this is going to be live data coming from that highway. And so this is the area that we are monitoring as a part of our detection system and warning. It's around 120 meters away from the LiDAR in each side, 200, 240 meters end to end that is being monitored. And as you can see, there is a near IR image as well that is generated by the system. So now if you look at our event recording, so within the time period that we were testing, so you can see there was warning, and then if you play that, so you can actually evaluate the system from the false positive, false negative perspective. So as you can see, this is one of the cases. The car we actually did close the road to test the system. So you see that there is a vehicle here that is going wrong way, and this is the event that the system captured and generated the warning. So, and then, as I mentioned, one of the important use cases of LiDAR is that since we can extract accurate speed location of the object, we can actually use this system for V2X application. For this project, we are sending we have our system installed at the intersection, and our system generating basic safety messages based on J2735, and then it's communicating to the roadside unit, which is connected to our edge computer. And roadside unit is broadcasting this information to connected vehicles. We had a pilot car for this POC that has an onboard unit. And as you can see in this video, there's going to be a warning for driver that there's a cyclist. But as a cyclist, you don't see, as a driver, you don't see that cyclist because it's behind the building. And if it played, that was the actual cyclist that was captured by the system. So this is really important to look at this technology as a multimodal detection system that not only serves the current demand for the ITS, like actuation data collection, but it's also ready for using this for more advanced use cases like V2X use cases, as I've shown here. And then we use our system for highway monitoring application, and we just wanted to quickly show some slides about some live data from that as well. This is another project. It's in Utah. Just logging again. For this project, we have basically virtual loop concepts, very similar to inductive loops, but virtual loops that are connected to, it's collecting the presence information. So this is using one of our single LiDAR, so you can see actually the coverage area. And then if I disable the points, you can actually see that all the cars, we have virtual loops, and with this information, we are extracting occupancy ratio, average speed count for all the different type of vehicles that we have at this intersection. And this data again is live data coming from that deployment. So going back to the slides. So again, to just summarize what we discussed today is the goal of building Blue City is to provide a turnkey solution This is really like a solution that is ready to plug and play and get access to the data without like getting different components from different companies or data providers. So I think we discussed everything, and so now it's time for Q&A.
Thank you, Assad. And thank you, Itai. That was great. So just a quick reminder for everybody, obviously we're going to get into the Q&A, so please chime in with more questions, but thank you for everybody who put in questions as Itai and Assad were speaking. So I'm going to get into those, but just a reminder, put in a question to the Q&A box if you have anything that you want to hear more about. So we got a few questions as you guys were speaking. I'm going to go through them in the order that we got them. So first off here, question one, how do you address occlusion of the laser beams? Is there a recommended mounting height that's ideal to minimize occlusion at intersections?
Yeah, we typically install LiDAR between 4 to 6 meters. For highway application, we put higher, but for intersection, typical installation between 4 to 6 meters high. And the fact that we can actually stitch point cloud coming from two LiDARs actually help with minimizing the occlusion problem. So for example, in this case, if there's a heavy vehicle at the center of intersection, which is occluding an object on the other side, but the other LiDAR will capture that information. So since we are fusing data coming from multiple sensors. So this is basically the way that we can minimize occlusion.
Yeah.
And I want to maybe just also specify, if I may, to add that the both LiDARs work on the same edge computer. That does not require an additional edge computer.
Correct.
And I'll pile on as well, just noting that the sensors are also installed at the corners of the intersection. So it's not required the install doesn't require shutting down traffic in any direction or any of the roads. So you don't need to install it on any of the overhanging infrastructure in an intersection. It's all done just via usually a traffic pole on a corner and mounted to the pole itself.
Yeah, this is a great example. As you can see from one LiDAR, there is another car the other side of it, but it's occluded, but you don't see it. But if you look at the other side, actually it sees the other car, which is this one. So yeah.
Perfect. Great. So next question. This is more about what we can capture with the system. So the question is, are you able to differentiate U-turns from left turn movements?
Yes, we have turning movement counts. Currently, we're not reporting U-turns as a part of our turning movement counts, but we are capturing this information. So we always have the heading and direction of the objects as a part of our API as well. But currently on the dashboard side, we're just reporting left turn true movement and right turn movements when it comes to the count, access to the count.
Yeah, to kind of repeat that back, basically, we have the data clarity and specificity to easily differentiate between left turns and U-turns because we track the heading of the vehicle at all times. So currently it's not in the dashboard, but if that's something that's a problem at a specific intersection, talk to us. We can put that is something that we can do with, kind of minimal adjustment to our system to add in the ability to track U-turns as well, like U-turns as differentiated from left turns. Great. So question 3, there are a lot of companies that don't have an on-hand tech team to install and set up the sensors. Can a company hire Ouster to come to their facility to set everything up?
I can take that. I think that we have an interesting ecosystem of partners not only in the United States, Canada, but also in Europe and Asia. And those partners can definitely help with they're certified, trained with our solutions, and they can help with those on-site installations if required. So just like you mentioned before, Tom, let's talk to us about the specific location, and we'll be able to point you to our local partner there that can help you with that work.
Yeah. And one other thing is that from the installation perspective, it typically takes less than 2-3 hours for installing the system. We don't need to have a road closure. We don't need to have a mast arm to install the system. That makes it really easy. And the fact that our configuration tool is supporting a cloud-based system, so you can actually just install physically the system and then doing all the calibration, drawing virtual loops, everything remotely. So you don't need to be on site to do the calibration of the system.
Perfect. Great. So next question. So what vehicle classification levels are you able to detect and collect in the system?
Currently, we have the three major classification for vehicles: passenger vehicle, truck, and buses. And then for trucks, we have subclasses because we are classifying as a subclass trailer and tractors as a two separate objects. And then more subclasses can be built based on the length and width and height of the trailer. So, for example, if the trailer is less than 10 meters, that could be one class, and then another class based on the length. So as you know, the any non-intrusive technology, we're not based on axle counting. It's based on the type and shape of the object. And then subclasses can be built based on the length, width, and height of the object that we generate with our system.
Perfect. And then I'd just add the two other main classes that we support are pedestrians and cyclists as well. Great. So next question, how does rain affect the accuracy of the detection?
So when we started Blue City, and then it was acquired by Velodyne and Ouster, we started from Montreal in Canada. So as you know, it's the worst case scenario for developing a traffic actuation system because of the rain and snow. So we have actually several different case studies that we actually shows the performance. I'm just trying to see one of the slides that we had um, for yeah, this one. This one actually was a when we had a snowstorm in Ottawa in Canada, that you see like how noisy the data is when it comes to the like camera view. You barely see vehicles because it was during night and it was during a snowstorm. But the fact that our LiDAR is using its own source of light, this is one way that improves the system performance. And the second is that we use deep neural networks for detecting object, which is a part of our perception software. And using deep neural network, we train our perception over thousands of frames over the past couple of years, collected from different locations. And we trained our model to address all those noisy returns that we might have. And when you look at the actual point cloud generated as a part of our perception, you can see that there is no noisy detection even under this snowstorm. So, and typically LiDAR is not affected by the sun, direct sun glare. So these are the things that the system performs really well. We have a couple of different case studies. If you can, if you like to get access to that, please reach out to us and we can provide those reports.
Perfect. Next, what is the latency to get input into, from the system into the traffic controller?
Yeah, the end-to-end is typically from the time that object gets into the detection zone of the LiDAR till we report. It's typically around 200 millisecond, 100 millisecond to generate a frame, 100 millisecond to process that frame, since everything is running real time. And then you might add some latency about network connection, but since connection to the traffic controller is over a wired communication or through a SDLC, there shouldn't be any extra latency. It's very fast. So I would say like between 200 to 300 millisecond is the safe case for as a worst case scenario.
Perfect. So let's see. We had two kind of similar questions. Let's see. One is, can you clarify if the edge computer used in the solution is proprietary or if the solution can be installed on other edge devices?
So we all we need to make sure that we have the GPU processing because we use deep learning in the edge computer. Potentially, we can use other edge computers with enough GPU on it. So we use NVIDIA Jetson or an AGX currently with our system. We have our own edge computer because we wanted to customize it to meet NEMA TS2 certification, so which we recently passed that certification for our edge computer. But in general, for scale, if there are like needs for using other edge computers, we can potentially use that. So, yeah.
Perfect. And relatedly, is the connection between the LiDAR sensor and the edge computer also, is that proprietary, or can that be a standard Ethernet cable?
So it's all standard Cat6 Ethernet cable. So you connect. We provide a PoE splitter as a part of our system. So you just need to basically connect the Cat6 cable from the edge computer to the PoE splitter that we provide, and the edge computer will power both lidars. So you don't need to have any extra PoE injector or anything. So yeah.
Perfect. Last one, kind of related in the same vein. Does your edge computer connect with the existing controller at the intersection for control?
Yeah, so as I mentioned, we support NTCIP and SDLC for standard controllers. Uh, I would say probably we tested already. We all different type of vendors that we have in the US market in different projects, from Econolite, Intolite, McCain, Peak controllers, etc. And then for like some legacy controllers or for projects in Europe that they don't necessarily support NTCIP or SDLC, we use dry contact output. So we use Moxa adapter as an Ethernet to dry contact output for those legacy controllers.
Perfect. And then we got two kind of V to X related questions here. One is, can you clarify if your solution transmits basic V to X basic safety messages to vehicles and road users?
So we have a library that converts all the object data based on J2735 standard and builds BSM and PSM formats, but we don't have the RF module on our system. So what we typically do, we send this information to the RSU roadside unit, like from different vendors over UDP packets. We have done some other integration, for example, with Verizon Virtual RSU in a project in Rutgers, which is there's no RSU. We're sending this to Verizon MEC, and Verizon is actually broadcasting basic safety messages over their virtual RSU, which helps with reducing the cost of infrastructure if we take this approach.
Perfect. And I think this is kind of implied based on a project with Verizon, but can the communication be transmitted over 5G wireless connections?
So yeah, that's basically what we do in
Yeah.
Verizon project. They're using their network, the Verizon network, for that project. But yeah, it just adds the latency because latency of RSU or LTE networks are different. But if it's 5G, we can't guarantee the latency. So the answer is yes, but it depends on if there is a infrastructure in place.
Perfect. And if there are traffic cameras at the intersection, can the LiDAR, connect or integrate with those cameras in any way to, provide consolidated information?
So right now we are not connecting pulling any camera feed. And the reason is that first, we believe that we don't really need to do that because as you probably saw here, we have really great resolution. You can actually even use the near IR image. However, like we use this integration with VMS for our security application for intrusion detection. This could be potentially integrated down the road, but right now we're not. We are not actively working on camera integration.
Perfect. And just one question, where are the LiDAR sensors manufactured?
So we have two manufacturing plants. One is in San Francisco that if the system needs to be Buy America certified, so we have a manufacturing plant in San Francisco, and then our volume manufacturing plant is in Thailand.
Okay, great. Perfect. And I think we got the last question here, but I kind of punted this one and saved it. But what is the typical pilot installation? Like, what does the typical first installation look like?
So the answer is it's very simple. So actually, I think we have one slide for probably talking about different components. So as we discussed, BlueCity is a bundle solution that has the lidar, it has the edge computer and everything. So all you need is really to get our bundle, and you need an AC power and internet. That's it. So you get all the access to the data. Even if you want to evaluate for traffic actuation, you don't necessarily need to connect to the traffic controller. You need, even if it's connected, you don't need to do actuation to evaluate the system. This is one of the benefits of our system, that you can easily evaluate the system performance with just getting access to the AC power and installation.
Perfect. And actually, uh, one last minute follow on to that one, which is, can you talk at all about what the typical cost per intersection is?
Vitaly, you want to talk about that? Hard question.
Yeah, I think that we are today, we have two bundles. One bundles with a single LiDAR that fits the smaller intersections, and bundles with dual LiDAR that are meant for medium and larger intersections. And the pricing in terms of cost has two components. There is an upfront cost for all the material that goes into the intersection, everything that you see on the left hand, which means the lidar sensors, the edge computer, the PoE splitters, and the mounting accessories. And then there is a access to the dashboard for the analytics, and that is a subscription per intersection per year with unlimited number of users. And the pricing itself is very competitive and will be matching what you today are used to invest for intersections, actuations, and analytic systems from any other vendors. It will not be very different.
Yes. And if you do want to know more, I mean, our pricing, as with all of these systems, will depend on the size of the deployment and what the project is. So, because there obviously is a lot of upfront cost in just getting everything set up and situated and everyone trained, and so please just reach out to us. Give us a little information on your project, and we can talk to you about pricing. We're no intent to be cagey, but it does depend project to project what we do. But it's very competitive with the existing camera and radar solutions on the market. We're very aware of them and recognize that uh, our goal is to provide more capability at a lower cost than the existing solutions. So please reach out. Great. So with that, we're at exactly the top of the hour. So um, thank you, Atai and Assad, for all the expertise and all the answers on this. We are going to have another webinar coming up in September. We'll be announcing the customer soon, but we have a major deployment. It's tens of intersections plus across the city. We'll share more details, but it's a very large deployment of lidar across intersections, and so we just need the final confirmation that our guests will be joining us, and so we'll be sharing that in the next week or two.